My name is Marie Bowen. I'm Principal Research Scientist in Ruminant Nutrition with DAF based in Rockhampton. The title of this presentation is called Maximising Beef Production and Profits Using High Quality Forages. In this presentation I'll be summarising the outcomes from our recently completed project called High Output Forage Systems for Meeting Beef Markets Phase 2. This project was a DAF and MLA co-funded project. It ran from 2011 to 2015, and the overall objective of this project was to examine the relative production and profitability of key alternative forage options that could be used for either backgrounding or finishing beef cattle in the Fitzroy River catchment of Queensland. So this was the target area for our project, the Fitzroy River Basin, and what we were really doing here was focusing in on the high quality or higher quality soil types within the region that would be equally as suitable for supporting a grain crop as for growing a good quality annual forage or a good quality perennial grass pasture system. So in this project we were working with commercial producers as cooperators in our project, and what we were really doing was benchmarking what was happening commercially on these properties. So we didn't ask producers to change their practices at all. We were measuring what producers were doing commercially. And over the course of 2011 to 2014, we ended up monitoring 24 forage sites across 12 producer properties over that period. We focused in on 3 key annual forage types, namely oats, forage, sorghum and lablab, 2 high quality perennial systems being butterfly pea grass systems and leucaena grass, and we also had a number of perennial grass only pastures as a baseline for comparison to the higher quality forage options. We tried to spread these sites fairly evenly across 3 arbitrary regions within the Fitzroy River Basin, these being what we call the Central Queensland Open Downs area, so up around the Emerald Capella area, the second region being the Central Queensland Brigalow region, so around Biloela Ralston, and the Southern Queensland Brigalow region around the Troom Wandoan area. At each of these forage sites or paddocks we took detailed measurements to monitor forage, animal and economic performance from each of these paddocks, and in total we ended up with 31 individual data sets, so they were annual or part annual data sets. And just to give a quick overview of the sorts of measurements we were taking, the first photograph here shows the setting up of a weather station which logged rainfall and temperature remotely at the sites. We also took soil cores which we used to monitor soil water content and nutrient content at the sites. We took a large number of forage measurements so that we could measure forage yield or biomass in both the grazed and also ungrazed areas for the annual forages. And we also did analyses so that we could determine forage quality as well in terms of crude protein and digestibility. We took fecal samples so that we could estimate or get an estimate of what the quality of the diet was that the cattle were consuming in terms of protein and digestibility, and of course we also monitored the live weight gain of the cattle. And finally we collected as much financial information as we could for each of these sites so that we could determine paddock gross margins. So moving on to a summary of the forage production results from these sites. This table gives average figures, so averaged across all sites within each forage type. You can see that the data for the annual forages is over here on the left-hand side of the table and the perennials over here on the right-hand side. In the first row, the data gives figures for the biomass measurements in the grazed paddock, and in the second row, an estimate of total forage grown in the paddocks for the annuals. And this was determined from the exclosure sites, the fenced exclosure sites where cattle couldn't graze. And just to clarify with these measurements, the biomass measurements for the annuals were the peak measurements in either the grazed or the ungrazed areas over the period of monitoring, but for the perennials these values are the average biomass over the duration of monitoring. And just also to point out here, the leucaena biomass is the edible biomass only for the leucaena, so any material less than about 5 millimetres in diameter. So the key points from this table here are, as expected, forage sorghum resulted in the greatest biomass of all the forage types. So the biomass was expressed in kilograms of plant dry matter produced per hectare. So forage sorghum was a standout in terms of biomass produced. When we're looking at quality of the diet, oats was a standout, as expected in terms of it being a temperate or C3 plant. When we talk about quality, the key measures here are crude protein, so abbreviated as CP, and digestibility of the material. So that abbreviation DMD stands for dry matter digestibility. So the key point there is that oats was a standout in terms of producing a very high quality diet for the cattle, but the legumes, lablab and leucaena grass also provided a very high quality diet, not far behind the oats diet. Just to highlight some key management issues that became evident during the course of our project. At the majority of our sites, generally soil fertility was low and fertiliser application was really not common practice. So as a general broad comment, we conclude that across the Fitzroy River catchment, most or many annual forage crops are likely to be limiting in soil nitrogen and phosphorus for production, and the perennial legume grass systems are likely to be limiting in phosphorus for their production. So as well as limiting the productivity of the forage, this can also have issues for the diet quality for cattle, in some instances if severe. And just an example to highlight the most extreme case that we came across in our project, we monitored an oats crop near Taroom in the 2011 year, where the soil nitrate nitrogen at planting was only 42 kilograms of nitrogen per hectare, and the corresponding green leaf crude protein at the start of grazing was only 4.5%, and that's a photograph of the oats crop there. You can see it's looking quite yellow. So at that crude protein level, the performance or the growth rates of the cattle would have been limiting. So that's an extreme example, but it's one that we had observed during the course of our project. If we move on to a summary of the beef production results, we express these results in terms of kilograms of beef produced per hectare per year. So this is the beef produced from each of these paddocks and averaged within each forage site. The numbers on top are the average across all sites, and the numbers in brackets below give the range across sites. So it's interesting there to see that there was quite a large range across the sites that we monitored. The key point here is that all of the sown forages increased beef production compared to perennial grass only sites on average, and leucaena grass pasture was really the standout system, producing over 2.5 times the beef output as compared to perennial grass only, so on average. The other key point here is that forage sorghum really produced quite similar beef production to our oats and lablab forages, although if you remember back to the forage biomass table, it produced twice as much biomass roughly as the oats and lablab, and that is because generally speaking the forage sorghum wasn't efficiently utilised, which brings me to my next slide. So one of the key management issues that was identified as part of the project was that grazing management of forage sorghum was often limiting the productivity and profitability of these paddocks and these systems. Generally speaking, grazing started too late and the stocking rates were too low. So the issue here is that the plant was already quite mature when the cattle commenced grazing, or it matured too quickly. The stocking rate was unable to keep it in a vegetative state. So the stocking rate was too low. And the issue here is that a poor quality diet was provided to the cattle. You know, there's all those stems there that are low in digestibility, and a lot of the crop is wasted, so it's poorly utilised. So that was a real issue with our forage sorghum. Another important management issue in terms of the cattle production is that we found that the vast, or a large proportion of our sites, a significant proportion of cattle were returned to grass after grazing a high quality forage. And that's an issue because cattle returned to perennial grass pastures lose that live weight and financial advantage due to what we call compensatory gain effects. So what that really means is that cattle that haven't been given access to the higher quality forage will catch up with their growth rates, and they'll catch up to the cattle that were provided the higher quality diet over the ensuing season. And so that has a real effect on the profitability of forage feeding. ways to tackle that are better monitoring of cattle weight gain over the period of feeding, and adjusting stocking rates if possible to help maximise the number of finished cattle. But that was a big issue that was highlighted as part of our project. When we look at measuring profitability of these individual forage systems, we use the gross margin, which is the most common way to do that. And we expressed our gross margins on a per hectare per annum basis. In simplistic terms, the gross margin is livestock sales minus all variable costs. And so that we could compare the perennial forage systems to the annual, so obviously the perennials having a life of greater than 1 year, we needed to use a slightly different technique, and what we did was we amortised the development costs over the expected life of that forage, and amortising means determining an average annual cost over the expected life of that forage type. This table gives a summary of the gross margins within each forage type. The first row also gives the forage costs in terms of dollars per hectare per year, and once again the range of values is presented below the averages in brackets here. The key points to make from this table of data is that the forage costs, the annual forage costs for the annual forages, being oats, sorghum and lablab, were generally quite a bit greater than the annual cost for the perennial forages, and that's because these annuals are being replanted every year. When we look at the gross margin result, the standout performer once again was the legume-grass system. The average gross margin for legume-grass systems across all sites were almost 2 times greater than the average from perennial grass only sites. Butterfly pea was the next highest performer, with the average gross margin being around 1.5 times greater than that from the perennial grass only sites. While oats produced a greater gross margin on average than our perennial grass, the sorghum and lablab sites produced a lower gross margin on average than the perennial grass sites. So the profitability in terms of gross margin was the combined result of our forage and beef production results, which we've already highlighted, the forage costs, and the other important factor that we haven't mentioned yet is the cattle price margin, and that is the sale price of cattle less the purchase price, the units being dollars per kg live weight. And in the course of this project, we determined that these gross margins are really very sensitive to that cattle price margin, so it's very important to be aware of that. And of course, all of these factors are influenced by management, seasonal and market factors. However, it's very important to be aware that the gross margins are really only the first step in determining the effect of these sown forages on farm profit. So they're showing us whether the forage activity makes a profit or a loss at the paddock level. But these positive paddock gross margins don't necessarily mean that the forage type is going to be the most profitable option compared to other alternative uses of the land. And so to determine the value of these sown forage systems to the whole farm or business, a more complete economic analysis is required. And these are called profit budgets or whole farm economic case studies. And what they do is they determine the value of the sown forage system to the whole farm or business relative to other alternatives that could be performed in that area of land. So, for instance, it might be leaving the area as perennial grass or planting a grain crop. And these economic analyses compare the net profit generated by these alternative forage systems, and they consider differences in unpaid labour, herd structure and capital between the different systems. So they're incorporating additional costs that aren't captured within the gross margin analysis. We conducted 5 of these economic case studies with 5 different producer cooperators within our project, and the key conclusions from this work was that the perennial legume grass pastures, and particularly leucaena, currently have a significant economic advantage over annual forages and perennial grass pastures. However, they are not as profitable as grain cropping, where that is a feasible alternative for producers. On the other hand, the annual forage crops generally only add value to the beef enterprise if the opportunity cost of plant and unpaid labour are excluded. So just to conclude, I'd like to highlight a couple of the key products and tools that have been produced in this project. The first being our book called Feeding Forages in the Fitzroy. It's designed as a producer guide to forage use, and it contains example economic analyses and a summary of the data that was collected from the cooperator sites as part of the project. Hard copies are available, or additional copies can be downloaded from the web as a PDF, and that's the address that it can be obtained at, presented here. We also developed forage gross margin spreadsheets, which can also be downloaded at that address, and these contain example gross margins for the forage systems, and these examples are the same as the ones we've presented in this book. And as well as that, you can enter your own figures and modify the data in those spreadsheets so that you can calculate gross margins for your own particular business and circumstance. So they might be worthwhile having a look at. And if you're interested in any additional data or information about the project, interested in looking at the full set of results, then the final report can be downloaded from the MLA website at this address here. And just finally, I'd like to acknowledge the financial support of Meat Livestock Australia in supporting this project, and particularly keen to acknowledge the beef producer cooperators across the Fitzroy River catchment that were involved in this project. Without these producers, the project would not have been possible. So we're so grateful for their support. And finally, just the DAF project team. We had a large team working on this project, so I'd like to acknowledge our team as well. If there are any further questions or information that's required, please don't hesitate to contact me by phone or email. Thank you.